Hello everyone, I am Gopikannan. Welcome to our maths class. NCERT Solutions, Chapter 3 Matrices. Exercise 3.4, question number 15. Find the inverse of each of the matrices if it exists. Consider the matrix A equal to. We find the inverse of this matrix. So the first step, solution. We rewrite the matrix A, which is equal to I into A. Okay. Next we write, what is an A matrix? 1, 3, minus 2, minus 3, 0, minus 5, 2, 5, 0, which is equal to, I denoted as identity matrix for order 3. So we write 1, 0, 0, 0, 1, 0, 0, 0, 1. So into A. Applying elementary row transformation, we change this form I, which is equal to A inverse into A. This is of the form. Okay. So this matrix is called an inverse of the given matrix. So we are applying elementary row operation to change this matrix to identity matrix. So applying R2 implies R2 plus 3R1, because the identity matrix is 1 0 0. The first entry is non-zero entry and 1 also there. So we convert this entry to 0, this entry also 0. So the first operation is R2 plus 3R2. Okay. Then when we get 0 this element, we multiply the first row by 2 and subtract this row. We get this entry is 0. Okay. So we write R3 implies R3 minus 2R1. Now applying this procedure on this matrix, we get the first row there is no changes. We write the same row 1, 3, minus 2. Then applying this operation, 3 into 1, 3. 3 minus 3, 0. So the same way we can proceed 0, 9, minus 11. And also applying this procedure R3 minus 2R1. And we get 0, minus 1, 4. Which is equal to, we can applying same procedure for this matrix also. Okay. So the first entry is there is no change, 1, 0, 0, 3, 1, 0, minus 2, 0, 1 into A. Now see the matrix. The first entry is 1 and next two entries are 0, 0. So what is the condition for identity matrix for the second column? This entry is 0 and 1 and 0. So we change this 3 to 0 and 9 to 1 and minus 1 to 0. Okay. We can applying R1 implies R1 plus 3R3, because here minus 1 is there, here 3. So we multiply by 3 into the third row and adding with the first row. We get this entry is 0. Next, and R2 implies R2 plus 8R3. We change the entry is 1. Okay. Now proceeding, we get 1, 0, 10. Okay. Next 0, 1, 21, 0, minus 1, 4, which is equal to minus 5, 0, 3, minus 13, 1, 8, minus 2, 0, 1 into A. Okay. Next we see this entry is minus 1, we convert to 0. So we just adding this 2 row, we get this entry is 0. Okay. Now applying R3 implies R3 plus R2. We get this entry is 0. Now proceeding 1, 0, 10, 0, 1, 21. We get 0, 0, 21 plus 4, 25 we get. And this side we get minus 5, 0, 3, minus 13, 1, 8, and this row minus 15, 1, 9 into A. Next, the third column we convert this 0, 0, 1. Okay, now applying, but we can see this both entries are distinct entries. So any one of the entry we change to 1, that is the third row and third column. This entry we converted to 1 and the remaining we change to 0 is very easy. Okay, now applying R3 implies 1 by 25 into R3. Okay, so we proceed 1, 0, 10, 0, 1, 21, 0, 0, 1. So which is equal to, we get minus 5, 0, 3, minus 13, 1, 8, and we multiply by 1 by 25. Okay, we get minus 3 by 5 and 1 by 25, 9 by 25 into A. Okay, now we change to 0 for these two entries. It is very easy because we multiply by 10 and subtract with the first row, we get this entries 0. Okay, we write this procedure, that is R1 implies R1 minus 10 R3 and R2 implies R2 minus 21 R3. Now proceeding in the same manner, we get 1, 0, 0, 0, 1, 0, 0, 0, 1, and this side we get 1, minus 2 by 5, minus 3 by 5, and minus 2 by 5, here 4 by 25, and 11 by 25, and minus 3 by 5, 1 by 25, and 9 by 25, and completes this square matrix. So this is into A. This is of the form I, which is equal to some matrix, that is inverse of the matrix into A. So this is an inverse of the matrix. So next, sum number 16. We consider the matrix A, which is equal to the 3 by 3 matrix, and we rewrite the given matrix A, which is equal to I into A. We are applying elementary row operation and we get this, the final form is I equal to A inverse into A. This is an inverse of the given matrix. Okay, now proceeding elementary row operation. Okay, now applying, first we write the matrix, that is, what is an A matrix? 2, 0, minus 1, 5, 1, 0, 0, 1, 3. Okay, which is equal to identity matrix for order 3 is 1, 0, 0, 0, 1, 0, 0, 0, 1 into A. We are applying elementary row operation and we get the left hand side matrix is converted to identity matrix. So the identity matrix condition is 1, 0, 0. So the first entry should be changed to 1. So when we get this entry is 1, we can divide it by 2 in the first row and we get this entry is 1. Okay, so we are applying R1 implies 1 by 2 into R1. We multiplying by 1 by 2 in each entry in the first row. Okay, we get the equivalent matrix 1, 0, minus 1 by 2. The remaining two rows are, there is no changes, 5, 1, 0, 0, 1, 3. Okay, and the right hand side we get 1 by 2, 0, 0, 0, 1, 0, 0, 0, 1 into A. Okay, next this entry changes to 0 and already here the 0 entry are there. There is no change. So when we get 0, we multiply by 5 and subtracting this row, we get 0. Okay, so the changes in row 2. So row 2 implies row 2 minus 5 row 1. 5 into row 1. Okay, we calculating in rough work and we get the final matrix for these operations. The R1, R3 there is no changes. So we write same entries. The row 1 is 1, 0, minus 1 by 2, and applying the elementary operation, and we get the answer is 0, 1, 5 by 2, and row 3 there is no change, 0, 1, 3, which is equal to, we get this side 1 by 2, 0, 0, minus 5 by 2, 1, 0, 0, 0, 1 into A. Okay, we look at this identity matrix. For the second column is the entry 0, 1, 0. Here 0 is there and 1 is also there, so this entry changes to 0. So we subtracting these two rows, we get this entry is 0. So we applying the procedure R3 implies R3 minus R2. Okay, now we write the first two rows, there is no changes. So 1, 0, minus 1 by 2, 0, 1, 5 by 2, and applying this operation we get 0, 1 minus 1, 0, and 3 minus 5 by 2 we get 1 by 2. Okay, and which is we get here 1 by 2, 0, 0, minus 5 by 2, 1, 0, and this 5 by 2 minus 1, 1 into A. Okay, and the third column we can see this, we converted to this entry 0, and this is also 0, and this is 1. First we convert to this entry is 1. When we convert this entries are 0 is very easy, so we just multiply by 2. Okay, that is R3 implies 2 R3. We write down this first two rows 1, 0, minus 1 by 2, and 0, 1, 5 by 2. We multiply by 2 in each entry in R3, row 3. Okay, so we get 0, 0, 1, and which is equal to 1 by 2, 0, 0, minus 5 by 2, 1, 0, and here 5 minus 2, 2 into A. Okay, now we convert this entry 0, applying R1 implies R1 plus 1 by 2 R3, and here R2 implies R2 minus 5 by 2 R3. Okay, we get one, 0, 0, and here 0, 1, 0, and this is 0, 0, 1, which is equal to, we get this inverse matrix 3 minus 1, 1, minus 15, 6, minus 5, and 5 minus 2, 2 into A. Therefore, the inverse of the given matrix is A inverse, which is equal to 3 minus 1, 1, minus 15, 6, minus 5, and 5 minus 2, 2. Okay. Okay, question number 17. Matrices A and B will be inverse of each other only if AB equal to BA, or the option B, AB equal to 0, BA equal to identity matrix, or option C, AB equal to BA equal to 0, and option D, AB equal to BA equal to the identity matrix. And we know the one of the result is, if A is a square matrix of order M, A is a square matrix of order M, and we take if there exists another square matrix B of the same order M, okay, such that AB which is equal to BA which is equal to identity matrix, then B is said to be inverse of A. Then B is said to be inverse of A. This is one of the results. In such case, it is clear that A is the inverse of B. Okay. Thus, matrices A and B will be inverse of each other only if AB equal to BA equal to the identity matrix. Okay. I hope we are understand well. If any comments, we will comment on the comment box and we will improve further videos. Okay, thank you to all.